Greetings and welcome to STEM Inspired. Today's special guest is Kurt Zierhut. He is the Vice President of Electrical Engineering at Haas Automation. Listen and be inspired.
My name is Kurt Zierhut. I'm Director of, I guess we change the names too frequently. I'm the Vice President of Electrical Engineering at Haas Automation.
And what is rewarding about your profession?
The fact that we actually make something that's successful, that people use and people appreciate, and maybe they might even spend some money on it and give you money for it, but it actually works out. It created a company with a lot of people employed to get some stature in the world, that people recognize what you do, and we make things. Ever heard the term, the 3 ways to create wealth? Make it, mine it, or grow it.
Oh, yeah.
Well, we're not growing it and we're not mining it, but we make it here. We make stuff here that people need. I guess that's one of the ways to create wealth.
Do you have a personal connection to your profession, such as childhood hobbies or anything that led to your profession?
Well, how did this start? From a young, dumb kid, I was always playing with electronic parts. I was probably about 5 or 6 years old. My father gave me a battery and a little electric motor, and I realized that you connect them together, the motor turned. Wow, you can make a motor turn with electricity. Then I got an opportunity to work with Gene Haas in the early 80s, building simple little things that turned in motion. And the motion in the machines we built got more and more complicated until the full-blown CNC machines we build today are our major product. We probably haven't defined that in this interview, have we?
No, we have not.
Should go over that. Pictures, if nothing else. We need some pictures.
Yeah. What are some of the things you develop here?
Well, our product is a mill or a lathe. In a machine shop, they're the things you use to cut metal or shape and form metal. A mill would be the simplest thing. It would drill a hole. If you want to drill a hole, and it's not just a hand drill, it's a drill press. And an automated drill press that can drill many holes and move the part around and change tools. That's a mill that is typically called computerized numerical control. An old word from more than 45 years ago, but still applies to these things. They're automatic. They got programs in them. They got multiple tools and parts in them. They got people who walk up to them as operators. Literally, the guy opens the door, puts a part in, clamps it down, closes the door, and pushes go, start. Walks away for a while. The machine finishes. He comes back and gets it. We build the machines that do that.
Oh, okay. Wow, very interesting. And you said you built a lot of different things when you were younger. What were some of those things?
Well, I got interested in the computer electronics very early, before I even finished high school. When computer electronics, this would have been the late 60s, was so golly gosh darn new that there weren't little things and kits you could buy anywhere. But I also had a friend or two who were interested in electronics, and we could certainly make the simplest things work with radios and transmitters and electronic gadgets. But the automation didn't really start until the mid and late 70s. But the computers and the automation got together and became most of what I was involved in. Computer programming became the big hot thing for me in the 70s, going to school. And I did that for another 25 or 30 years. Even part-time while I was here, as mostly just a programmer. And then designing the electronics that goes into our machine. Then managing most of it, and a few other odds and ends things we get to do. I guess there's a backstory to this. The epiphanies in life. All right, you want an epiphany in life. I had an electric motor. I had a battery and a motor turned, and a very good friend, and we're talking about 6, 7, 8-year-old kids, went home and said, Dad, my friend has a motor that turns. And his dad's really sharp and says, well, I'll get you a motor that turns, but I won't have to rely on batteries. I'll get you a transformer to give you the low voltage to run that motor. And at the time, I was pretty new at this. And I'd heard of something called AC and something called DC. And I knew that my battery was DC, and it made the motor turn in one direction. If I reversed it, the motor went the other way. And I heard of something called alternating current that went first one way and then the other. And my friend had this AC power, and he connected up to the same motors, and he complained to me that his motors wouldn't turn. Or so, hey, I want to learn about that. Show me everything you can. I want to figure out how that works. I want to make me one of them. That wasn't so easy. I understood stuff. I could learn about it. Some of the simpler things, I could make it. I knew what was going on.
It's so like hands-on and creative, like you're building something new? Is that what?
It was always something new, and the ability to make something that ran itself. It operated, but you designed it, and it did things that nobody else could do, or that certainly others around you weren't doing easily, and was my own design.
What are your most vivid memories of school or your childhood memories?
Well, I guess school, I was always bored by school. And there was a teacher, I realized what was wrong. I was a young dumb punk of about 12 or 13 years old. And there was this gal, she was apparently a college teacher, and she talked about the other universe. And I was a young kid who knew everything, and I said, universe to us means everything. There can't be other universe, like there's an other everything. No, there isn't everything. That's everything.
Yeah.
But she kept referring to this term as other universes. And I didn't know what she meant until many years later I studied the history of astronomy. Well, it was 3 or 4 years later. When she went to school in the late 30s, college, they had first discovered other galaxies. You know what a galaxy is. We're in a big galaxy. Finally, people says, what's that fuzzy light out there? Oh my God, that's another one of what we're in here. And they called them island universes in the 30s. So some phrase was other universes. What else? I had an advisor at UCLA named Leonard Kleinrock. And he offered to some kids, hey, you want to study some stuff? We're doing stuff on long distance communications. We got a contract with the Army. It's called ARPA, and they want to make it a communication system across many universities long distance away. Communications is not that interesting a thing, but he was building this really fancy protocol, internet protocol. He called it IP. Huge, complicated books. He made a study on queuing theory. In any case, you know how, who was that vice president that said he invented the internet? Al Gore. Al Gore did not invent the internet. My advisor at UCLA invented the internet.
Really? Can you tell me about someone who's been the biggest influence in your life?
Somebody?
Yeah, either a mentor or a teacher.
Wow. Yeah, a couple of advisors at UCLA. Leonard Kleinrock, you know, the internet guy. Met a friend at a high school reunion in 1980. Probably as much as an impact on me and anybody else, anything else in my life. In 1980, he was running a small machine shop, and he had some simple little things he wanted to run. And we'd gone to high school together, graduated in 1970. And he wanted to automate them, and he needed a little bit of computer, like power electronics. And he realized, hey, I got this, and I'm kind of bored with the stuff I've been doing the last few years. Let's go design some stuff. So it was all part-time things. And, you know, 4 or 5 years later, the company was called Haas Automation. And the guy's name was Gene Haas. So probably more than anything else, that's the guy that had an impact on me.
What are some of the lessons he taught you, or, you know?
Work your hiney off until it works, because you know you can do it. You just got to actually convince the rest of the world and yourself that you can.
What advice would you give to children who would like to enter a STEM profession?
Read about it. Read everything you can. When you get an opportunity to work with it, whether it's a high school during the day class or something after high school, work with that. Whether there's a manufacturing educational class in school or a first robotics class in school, go do that. Or if it's something, you know, local group, you can join and do that. Their ability to access the electronics and the automation and the software nowadays that didn't exist in my time is so pervasive, and you can learn so much from it. Again, life is anecdotal stories. It was 2 years ago. We worked with many robotics classes in a local competition. I met many of these groups. I met the group that was from a school near Pasadena. They had some really sharp kids, and they had one gal, one 17-year-old high school gal in charge of this group of kids putting this first robotics robot together. And she had this little module they were going to put on one of each 4 wheels. They supply it to you from the first robotics group. You don't design it. This is what you use. Got a motor to turn it, motor to drive it in one direction. She didn't like that design. She decided she wanted to redesign it to do something better. So she sat down on the desk, the computer-aided design, the CAD system, and spent a long time to design what she thought was a better design. She went to some simulation software and says, yeah, that should be a better design. She went to the 3D printer and printed those parts and showed how they fit together. She went to our machine, the metal cutting machine, and made all those parts in metal and assembled a better module and put it in a robot and won some competitions.
And what advice or information would you give yourself when you were younger?
Keep studying, don't quit. What do you know about geometric growth? Some people would draw geometric growth or an exponential curve and say, well, look at that knee. Something magical occurs here at this knee, like technologies might grow for hundreds and hundreds of years, and finally at some critical point it starts growing massively. And there's a few futurists who talk about this, that between man and computers and electronics and software, we're reaching a point where there'll be a crux like that. But the mathematicians will tell you that's flawed. Because that geometric curve is actually the same shape everywhere. If you took that geometric curve and scaled it up or down, scaled it smaller, that knee point would appear to move different in time, but it would have the same shape. You understand?
Yeah.
It's a mathematical truth that was called an exponential curve. It is the same shape, it's scaleless. No matter what time scale or magnitude scale you look at an exponential curve, it's always the same shape. If I consider electronics that's growing at 10% a year, as long as I've known it for 45 years, you know how to do this? You say 1.1 raised to the 40th power grew by a factor of 45 times in 45 years. But in truth, what was a small part of our lives 45 years ago is likely 40 to 50 times larger and 40 to 50 times more capable, but it only grew a little bit each year. And if every year after that it continues to grow, in the next 45 years it's going to grow by that amount also. So it's going to be 2,048 times larger than it was the 90 years before that. But, I don't know, that's a long mathematical, complicated description too. I don't think there's going to be an uncertainty point in the future where suddenly everything goes, it's out of control. It's all something we as human beings do and evolve with.